Let's begin. Today's July 31st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 6, 9, 13, 17, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our middle digit, the square digit, and the Turing machine will let us know whether its value is even or odd. Criteria card B looks at the 3-digit solution, and the Turing machine will let us know how many 3s are in our solution. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will be comparing our middle and last digit, square and circle, and so the Turing machine will let us know whether the square value is less than circle, or maybe they're equal to each other, or perhaps even square is greater than circle. Criteria card D, again, looks at our 3-digit solution, and the Turing machine will let us know how many of the digits in the solution are even. Are there no evens? A single even? Maybe 2? Perhaps all 3 are even. And criteria card E, again, looks at our 3-digit solution, but will let us know a little bit about its structure, specifically if there's a pair in the solution, as in the example 131, or alternatively, there is no pair, but there are 2 scenarios. Either all digits are different, as in the example 134, or all digits are the same, as in the example 222. Now remember, the objective of today's puzzle is to find a unique 3-digit code that abides by all 5 criteria cards that we just discussed. And let's start off with an initial proposal of 314. So the first thing I want to test is I want to find out a little bit about that middle digit. So let me go ahead and test criteria card A. Okay, so the Turing machine approves. Notice I did choose an odd 1. So the Turing machine just confirms that yes, the middle digit is an odd digit. So let me go ahead and put that in our notes in section A. Now it doesn't mean that the actual odd digit is 1. It just is confirming that it is odd. Okay, and since it is odd, that means I can actually cross out all of the evens for square. So I can cross out 2 and 4. Next, I think I'll like to test criteria card E. Okay, so in this case, the Turing machine does not approve. Notice I do have in my proposal 314. They are all unique, so that falls under the no pairs scenario. But the Turing machine does not approve of that, so it's actually telling me that there is a pair in our solution. So let me go ahead and type that up in our notes. Okay, so it could be that, this odd digit that we have for square might be paired up, or it could be that triangle and circle are the paired up digits. We just don't know yet. And we really can't cross out anything because of that. So there are a couple of interesting things we could do. There is this criteria card D that tells us how many evens. I do have 1 even. But if I get it wrong, it either means that there are no evens or there are 2 evens, since we know that square is already odd. We also have criteria card C, where square and circle might be equal if this middle condition is met. So let's see. I think I'd rather test C. See if there's something. even though my square and circle are not equal, I want to go ahead and test criteria card C. Okay, so in fact it is true that square is less than circle. So let's go ahead and put that in our notes. And that was criteria card C. So we know that it is true that square is less than circle. So what does that reveal about our solution? So square is to be less than circle. That means square can't be a 5, because if square were 5, there would be nothing larger than 5. So that's why square can't be 5. And I think similarly, circle can't be 1, because if circle were 1, what else could be smaller than 1? Nothing. Okay, well that does it for this turn. We have completed our 3 Turing tests, and we're moving on to the phase where we'll be discussing how to construct a good second round proposal. So notice that we didn't test criteria card B, finding out how many 3s there might be in our solution, and we didn't test D, the number of evens. But I think A, C, and D, even though we did get an X, we are resolved. So we know there is an odd digit for square, and we know that square is smaller than circle, and there's definitely a pair. So, and everything is up for grabs. We have all the possibilities of equal, well actually, so yeah, let's discuss that. So we know obviously in fact square and circle are not equal. So again, it must mean that either triangle and circle are equal or triangle and square are equal. So let's do the example. Let's talk about, let's see if triangle and square are equal. So that means that we have either 1, 1 or 3, 3. And I suppose maybe criteria card D would let us know whether there'd be an even or not. So this would be 2 odds. If there is an even, well, I don't know. I guess it would have to be 2. So it would have to be 3, 3, 2 for there to be a single even, because again, we do know that, oh no, I apologize. Square has to be smaller than circle. Okay, so it would be 3, 3, 4. But what if it were 1, 1? Is it 2 or 4? So that may mean that the solution would be, let's see, yeah, 3, 3, 4. Because it would be ambiguous 1, 1, 2, or 4. And similarly, if it is odd, and I don't think you could have no evens, because then how would you distinguish between 3 and 5? That would be ambiguous. 1, 1, 3 and 1, 1. Oh, I guess, well, you do have criteria card B that tells you how many odds. Well, that's interesting. So I guess it could be 1, 1, 3 and not 1, 1, 5. So I retract that. You could have all odds, no evens, and a single 3. So you could have 1, 1, 3. What about the other case where triangle and circle are equal? Is that right? Triangle and square was what we discussed. And yeah, triangle and circle. Obviously not square and circle. So triangle and circle. So that would mean that you would have either 2's on the outer, and then the middle would be 1 or 3. but it couldn't be 2, 3, 2 because again, square has to be less than. So I guess it could be 2, 1, 2. 2, 1, 2, 3, 1, 3, 4, 1, 4. Yeah, there's still quite a number of possibilities. 4, 3, 4. Yeah. So how many threes are there and how many evens are there? Let's see. So yeah, there's got to be a way where we know for sure. See, there's no mention of triangle. So triangle is going to have to be forced into something. And it seems to me that either it's going to be our 3. Well, no, it can't. Let's see. Yeah, how is triangle going to be forced to be? Maybe even? Well, no. If triangle were even, then that would mean that it would be equal to circle, which is possible. But how do you determine that? I guess you would say there's 2 evens. That's the only way you could say for sure. And then that would mean that, yes, triangle and circle are equal. And there could be a single 3. So that would mean that it would be like 4, 3, 4. That's possible. I'm trying to think of what other way. Yeah, I'm going to go with 4, 3, 4. I'm going to say that, yeah, that there are 2 evens. So let's see what happens. So 4, 3, 4. Well, let's test criteria card D. Okay, yes, indeed, there are 2 evens. So that was card D, and there are 2 evens. All right, which means that, of course, let's go ahead and cross out all of the odds. Since square is the only, or the odd one, that means that triangle and circle must be even. So yeah, let's cross out the 1 and 3 and 5 for triangle as well as circle. So let's go ahead and cross out 3 and 5. Okay, and because we know square has to be less than circle, I think everything's okay. Yeah, you could have a 1 and you could have a 3. But I don't think square could be 1. If square were 1, how would you pick between 2 and 4? I don't see that. So I don't think it could be a 1 because 2, 1, 2 and 4, 1, 4 would be ambiguous. Yeah, I don't see any way about it. So yeah, and so I think that means we can deduce. Well, can we deduce? Give me a second. Yeah, I think we can deduce that there's a 3. What else? Well, there is nothing else to pick for square. It must be a 3, and therefore, yeah, it is going to be 4, 3, 4, because obviously 2 will not work. Okay, so yeah, I think that's our solution. So let's go ahead and type it up. So 4, 3, 4. And we're deducing that there is a single 3. Okay. All right, well, let's go verify with the Turing machine that the solution is 434. All right, fantastic, well done. And so let's actually see how we did versus the Turing machine. I think the fact that we were able to deduce B, that there's a single 3, so beneficial. We only did 4 tests out of 5 criteria cards. That's always a, historically speaking, a winning combination. So we did A, C, E in the first round and then D in the second round. So A, C, E. So A, C, E, and I think E was incorrect. In the second round, again, we deduced B, but we also got D correct. So how do we do? Yeah, so we beat it by 2 questions. So yeah, it really did help out sort of talking through it and having been able to deduce that there was a 3. Okay, well, if you noticed anything else, please add your thoughts in the comments. If you liked the video, please give it a thumbs up, and if you don't want to miss out on any future videos, make sure to hit subscribe to be notified. Well, until next time, have a great one.